Hello all, welcome to the third video of laws of motion. In the first video, we studied about the first law of motion. In second video, we studied about the second law of motion. And now in third video, we'll be rewinding the first and second law and studying about the third law of motion. Let's again revise the first law of motion, which is also known as law of inertia. And the law is an object will remain in its original state of rest or continue to be in uniform motion unless and until acted upon by an external force. So this was first law of motion, which we studied in detail in our first video. Now moving towards the second law. And again, for revision purpose, we are reading out the second law of motion, which is also known as law of acceleration. The acceleration of an object in motion. Acceleration of an object in motion is directly proportional to the net force acting on the object, and inversely proportional to the mass of the object. The acceleration is directly proportional to force and inversely proportional to its mass. This is second law of motion. Now let's move towards the third law. So Newton's third law of motion is law of action and reaction. Yes, it's very much applicable to even day-to-day life, right? किसी ने हमें कुछ कह दिया और हमने वापस उसको जवाब दे दिया. This is what? Action and reaction, right? उसने मुझे थप्पड़ मारा, मैंने उसको वापस एक थप्पड़ मार दिया, right? Gandhi ji doesn't say so, but this is equal and opposite reaction, right? So what Newton's third law says is to every action there is an equal and opposite reaction, right? Equal and opposite reaction. So what are the applications of these laws? A very, the most important application being the rocket propulsions, right? What happens is rocket propulsion. Rocket propulsion. What happens is when a rocket is propelled, right? It is like this. There's a lot many fire from here, and it is launched from Satish Dhawan Space Center, right? So here we launched this rocket, and what happens is this burning fuel produces hot gases, hot gases, right? And these hot gases exerts a force, right? These hot gases exerts a force. These hot gases are produced here, right? So they exert a force backwards and push this one, push these hot gases to escape through this vent, right? From the lower side of from the back of the rocket, lower side of the rocket, right? So these gases escape from this side. These escaping gases exert force on rocket to move forward. These gases push rocket forward, right? These gases are moving to the force is keeping this one towards downwards, equal and opposite force making the things to move this way, right? So this way and this way. So this rocket propulsion, this is rocket propulsion, and this is the most important application of Newton's third law of motion, right? And another application is a helicopter lift, right? We are having helicopters is having some blades, helicopter. I'm spelling it wrong. Right. Helicopter is this, right? Helicopter. Helicopter is having some blades. Those blades include pushes the wind and the helicopter is pushed upwards, right? So the helicopter lift is also an application of Newton's third law of motion. So there are some day-to-day applications we are having. While swimming, we push the water backwards and our body gets moved forward, right? Then when we bounce a ball, like we tip the ball to the ground and it bounces back, right? That is Newton's third law of motion, right? To every action, reaction, right? Then recoil of gun. Yes, another one. This is a defense application, recoil of gun. Gun, right? Gun is there, right? So a bullet is shot, bullet towards this side, gun towards this side, right? This is a big M, this is a small m, right? It is having a small a and this is this. Force is equal, so m a capital is equal to small m small a. Small m small a for bullet and big M big A for gun. And this is the acceleration with which the gun will recoil back depending on the mass of gun, mass of bullet, and acceleration of bullet, right? So this is also the application of Newton's third law. Then there is another application which is rowing of boat. Rowing of boat. ठीक है. Rowing of boat. How we row? We with an oar or paddle, right? So that pushes the water backwards and the boat is moved forward. Then there is one game we all know is tug of war, right? Some people here, some people here, right? They are pushing it this way, they are pushing it this way, they're pulling it, right? So this tug of war is also an application of equal and opposite reaction, right? So this is all about Newton's laws of motion. This is Newton's third law of motion. To every action, there is an equal and opposite reaction. So the first law being the law of inertia. The law of inertia being we require some force, some external force, some net force to move an object from to change the state of an object from its uniform motion or state of rest, right? Then second law defines the quantum of that force being applied, the net force being applied on an object to make it to rest or to make it make up an object from rest to motion, right? And that depends on the acceleration of that motion depends on the quantum of net force and is inversely proportional to mass of that object, right? And we are seeing the applications also, and that application, that derivatives are leading to those universal laws of gravitation and work energy equivalence also, right? Then third law of motion, to every action there is an equal and opposite reaction. So we are having a lot many applications of these laws. So this is all about Newton third law of motion. So for you all, hard work is your action and result is your reaction. So work hard, have a good result. Good luck. Thank you. Bye bye.